Hey, fourth grade class. I hope you guys are all doing well. This is your week 26, day 3 math corrections. As usual, please stop the video if you have not done it yourself. Do it first, and then come and check here to correct your work and to get a little lesson time. Hope you guys are all continuing your education at home. Keep up the work. All right, so let's look at the first problem. It says to estimate the answer 4/5 times 3. 4/5 times 3, estimate the answer. All right, I remember what estimating means. It means we can round the numbers first. This problem's a little bit different, though, because we haven't had to work with rounding a fraction to do the work. I'm hoping you guys were able to make your connection here. When you look at the fraction 4/5, I'm hoping you saw what I saw and realized that if we were to round that to a nearest something, 4/5 is pretty close to 1 whole. So I considered rounding that to 5/5, which we know is equal to 1 whole, 5/5, because estimate means to round. So 5/5, meaning one whole, times 3. 1 times 3, no problem, right? 1 times 3 is 3. So that's our estimated answer for the first one. Let's look at number 2. They want us to actually solve the problem 4/5 times 3 and then write the answer in simplest form. Simplest form, we'll remember that. We'll have to look at our answer and see if there's a way to make it better. All right, so remember, guys, multiplication is just repeated addition. So what we really have is 3 groups of 4/5. 4/5 plus 4/5 plus 4/5. Remember, when you are adding or multiplying a fraction, the denominator does not change. So our answer is still going to be in fifths. You have 4/5 times 3. Since our answer is going to be in fifths, we just need to multiply across the top. You have a numerator of 4, and you're multiplying that 3 times greater. 4 times 3. 4 times 3 is 12. So we have 12/5. Now, that's an answer, but I'm hoping we all notice that's a fraction greater than 1, and the directions said they want us to simplify. So 12/5 needs to be written as a mixed number. We need to pull out any whole numbers that we can. You have 12 1/5 pieces, and it takes 5 of the 1/5 pieces to have 1 whole. So if I count by 5s, I can do 1 whole and another whole. That's 10 1/5 pieces out of the 12 that I had. I only have 2 left. That's not another to make a whole. So our final answer is going to have 2 wholes and 2/5 remaining. 2 and 2/5 is the answer we needed to get to, since it asked us to write it in simplest form. Always, if you see a fraction greater than 1, rewrite it in its simplest form, which is its mixed number. All right, down to number 3. On number 3, it says the temperature at 5 p.m. was 45 degrees. 4 hours later, it had fallen 16 degrees. What was the temperature at 9 p.m.? All right, so making sense of that problem here, we know that it's 5 o'clock at, 45 degrees at 5, and then 4 hours later, it's going to be 9 o'clock. And we need to know the temperature that it is at that time, 4 hours later. And they said here that it had fallen 16 degrees, right? So I think this is subtraction, because if it says fallen, I know my temperature's gone down. I need to subtract the 16 degrees that it has fallen. So 45 take away 16 is the math problem we need to solve to find out what the temperature is at 9 p.m. So I went back and got things highlighted, the question circled. All right, simple subtraction problem here. We'll do the algorithm. I look in the ones, and I see that I have 5 take away 6, and I can't do that math, so I'm going to borrow from the tens. I had 4. I now have 3 tens left, and that 1 10 that I'm borrowing breaks down into 10 ones. We had 5 ones, so now we have 15 ones. We're all set to do the math. 15 take away 6 is 9. 3 take away 1 is 2. And our final answer is 29 degrees. That is the temperature it is at 9 p.m. And that makes sense scientifically. Usually as the day ends, as we move further into the night, the temperature falls, right? And then as the early morning hours start coming and the sun starts coming back up, things start to heat up again. Okay, let's look at number 3. What is this? Number 4, find the area. Ooh, they've already given us the area model. The dimensions, the length is 3, the width is 13, and I noticed they gave us the letter M afterwards. That means that they've labeled the unit. We would not label our answer in units. We would say meters, M for meters. Okay, so I solved this one with the partial products area model. I took my 13 and I partitioned it or broke it into its parts, 110 and 3 ones, expanded form. And then I drew my little line on the area model to show that I've broken this into two smaller area models. I now have a 10 by 3 and a 3 by 3 for solving. When I do 10 times 3, I get 30. When I do 3 times 3, I get 9. Now remember, partial products, we need to put the parts back together to get the answer for the overall area, 13 times 3, right? So the overall equation was that. Those are the two dimensions, 13 and 3. Or multiplying them together, we just did it in two pieces. So you put those pieces together, 30 plus 9, and you get back to 39. 39. Now, how do we label our answer for an area problem? You guys remember? Area is different than perimeter, right? Area, how many square units are inside? Perimeter, add all the sides. Perimeter, add all the sides. Area, how many square units are inside? You guys hear I'm saying square units. So we need to label our answer 39 square, but is it square units this time, or did they tell us the units? They told us the units. We're in meters, so we need to label it 39 square meters. All right, 39 square meters was our answer. Looking at the last problem for today, we have Emily, who was born on March 2nd, 1999. If her brother Evan is 3 years and 3 months younger, that means subtraction, right? Take away, younger than she is, then what month and year was he born? So she was born March 2nd, 1999. He was born 3 years and 3 months later on. Did I do that math right? Uh-oh. I think I did my math the wrong direction. Okay, well, I'm going to redraw this then. So let's see, guys. I actually, you know what I did at first is I did takeaway, and my answer, actually, I'll show you guys, and then I'll erase it, and I'll do it right. Show you guys, I make mistakes too. So I highlighted my information, and then I totally did it backwards. Younger means that he would be born later in time, not earlier in time. And guess what I did? I did 1999, the year she was born, and I took away 3 years. I was like, he's younger, take away. But I got mixed up here because think about this when we get to our answer. That would mean that 3 years before was 1996, and he was 3 months younger. So I started March 2nd when she was born, and I went 3 months earlier. 3 months earlier than March 2nd would make it December 2nd. And then I pointed out here that if I go December 2nd from March, that means I've gone back into the previous year. So instead of 96, it became 1995, December 2nd, 1995. Now, I thought that was the answer. I've even put it up here, December 2nd, 1995. But here's the thing. Let's think about if that answer makes sense. Emily is older than Evan. Evan was born 3 years and 3 months later, right? He's younger. So it doesn't make sense for her younger brother to be born in 1995 and Emily to be born in 1999. I made a mistake. So here we go. I'm going to say bye-bye to all that mistaken work, and we're going to rethink this. You know, my thinking is going to be a lot the same, but we need to go the other direction to make him younger than her. He needs to have been born at a date 3 years and 3 months later than her in time to be younger than her. Do you guys see that? Make sense? Okay, so let me just think this one out. 3 months later from March. March is the third month of the year. March, and then we have April 2nd. That'd be 1 month. What's after April? May. May 2nd, April, May, and then we have June 2nd. That is 3 months later, June 2nd. So I know that's a part of my answer. The month would be June. And since we've already figured out 3 months later is actually June 2nd, we could even write the date. So we'll say, even though they just asked in what month and year was he born, we can do the day too. He was born on June 2nd, comma, after that. And then let's figure out the year. It was 1999 when she was born. We need to go 3 years later. So 1999, 2000, 2001, 2002. There we go. So brother Evan was born in 2002. Boy, class, that was way, way easier of a math problem than what I had done originally, because with that last one, I had to remember to go back a year in time and stuff. So anyways, there you go, you guys. That is all for our daily math corrections for Wednesday on week 26. So again, I hope you guys are hanging in there. I care about all of you. I hope that you continue to practice your daily math and your daily reading. Continue to check in on Google Classroom every day for updates and extra videos from other teachers. Continue using Epic Books and Prodigy, and just really continue the learning as best as you can, you guys. I know this is a crazy time, but we do need to keep moving forward so that at least when we do get back to some normalcy next year, you guys all had some practice under your belt. I miss you guys a whole bunch. I'll see you soon.